Today I am going to discuss about expert system of module 6. The topic is rule-based expert systems. Before going to discuss about rule-based expert system, we have to understand about what is knowledge. Knowledge is a theoretical or practical consideration of a subject or a domain. It is also the sum of what is currently known, and apparently knowledge is power. Those who possess knowledge are called experts. Anyone can be considered as a domain expert if he or she has deep knowledge of both fact and rules and strong practical experience on a particular domain. In general, the expert is a skillful person who can do things other people cannot. However, most experts are capable of expressing their knowledge in the form of rules for problem solving. Knowledge is represented in the form of production rules, that is, if-then rule. For example, if the traffic light is green, then the action is go. Other example is, if the traffic light is red, then the action is stop. The term ruling AI, which is most commonly used type of knowledge representation, can be defined as if-then structure that relates given information or facts in the if part to some action in then part. A rule provides some description of how to solve a problem. Rules are relatively easy to create and understand. Any rule consists of two parts, the if part called the antecedent or premise or condition, and the then part called the consequent or conclusion or action. If antecedent, then consequent. This is the syntax of if-then rule. A rule can have multiple antecedents joined by a keyword and or conjunction and or distinction or a combination of both. If antecedent 1 and antecedent 2 and antecedent 3, then we can write the consequent. If the other example, if antecedent 1 or antecedent 2 or antecedent up to n, then consequent. This is the example of rule-based expert system. The operator identifies the object and assigns the value. Operators such as is, are, is not, are used to assign a symbolic value to linguistic object. Expert system can also use mathematical operators to define an object as numerical and assign it to the numerical value. For example, if age of a customer is less than 18 and cash withdrawal greater than 1000, then signature of the parent is required. This is the basic structure of rule-based expert system. Here there will be two parts. One is user part, other one is expert system part. The user is interact with the expert system through the user interface or IO interface. It allows user to query the system, supply information and receive advice. The aim are to provide the same form of communication facilities provided by the experts. The expert system interface employ variety of user styles including question and answer, menu driven or graphical interface. The final decision on an interface type is compromised between users' need and the requirements of the knowledge base and inference system. The main part of the expert system is knowledge base. Knowledge will be stored in the knowledge base in the form of production rule. The heart of expert system is called as knowledge base, which contains knowledge of a particular application domain. The knowledge base represented the facts and rules. In a rule-based expert system, this knowledge is most often represented in the form of if-then rule. This contains both general knowledge as well as case-specific information. Many systems also include knowledge-based editor. It helps the programmer to locate and correct the bug in the programmer's performance, often accessing the information provided by the explanation subsystem. They also may assist in the addition of new knowledge, help maintain correct rules index, and perform consistency checks on any updated knowledge base. The next component of an expert system is inference engine. The inference engine applies the rules to non-fact to deduce new facts. It includes explanation and debugging abilities. The inference engine applies the knowledge to solution of actual problems. The expert system must keep track of case-specific data, the facts, conclusions, and other information related to the case under consideration. This includes data given in the problem instance, partial conclusion, confidence measure of conclusion, and dead end in the search process. The information separate from the general knowledge base. Explanation subsystem allows the programmer to explain its reason to the user. These explanations include justification for the system conclusions in the response to how queries, explanation of why the system need a particular piece of data, why queries and where useful, tutorial explanation or deeper theoretical justification of the program's actions. These are the main components of the rule-based expert system. This is the explanation of rule-based expert system, that is knowledge base, database, inference engine, explanation facility and user interface. The next we have to look into the main players in the development team. This is the structure of development team. Here the end user will be there. They will have some expert system, and the expert system have domain expert, programmer, knowledge engineer. Then overall part will be controlled by the project manager. So the first team member is domain experts. It is a knowledgeable and skilled person capable of solving problems in a specific area or domain. This expertise is to be captured in the expert system. Then the knowledge engineer is someone who is capable of designing, building and testing an expert system. Here, he or she interviews the domain experts to find out how a particular problem is solved. The knowledge engineer is responsible for testing, revising and integrating the expert system into the workplace. Next team member is a programmer. The programmer is the person responsible for the actual programming, describing the domain knowledge in terms that a computer can understand. The program needs to have skill in symbolic programming in such that languages, Lisp, Prolog and also some experience in the application of different type of expert system shells. In addition, the programmer should know conventional programming language like C, Pascal, Fortran, Basic, etc. The next team member is the project manager. Project manager is the leader of the expert system development team, responsible for keeping the project on track. He or she makes sure that all deliverables and milestones are met, interact with the expert, knowledge engineer, programmer and the end user. Finally, the team member of expert system is end user. End user often called just the user. It is a person who uses the expert system when it is developed. The user must not only be confident in the expert system performance but also feel comfortable using it. Therefore, the design of the user interface of the expert system is also vital for the project success. The end user's contribution here can be critical. The characteristics of an expert system is as follows. An expert system is built to perform at a human expert level in a narrow specialized domain. The most important characteristics of an expert system is high quality performance. On the other hand, the speed of reaching the solution is very important. Expert system apply heuristics to guide the reasoning and thus reduce the search area for the solution. A unique feature of an expert system is its explanation capability. The expert system employs symbolic reason when solving a problem. Symbols are used to represent different types of knowledge such as facts, concepts and rules. Let us have a look into forward chaining and backward chaining. In a rule-based expert system, the domain knowledge is represented by a set of if-then production rules. Data is represented by a set of facts about current situation. The inference engine compares each rule stored in the knowledge base with the fact containing in the database. When the if part of the rule matches the fact, the rule is fired and its then part is executed. Let us have a look into the example. Inference engine cycle via match fire procedure. Here the database contains fact like A is X. This is compared rule stored in the knowledge base. Rule is equal to if A is X then B is Y. Here there is a match occur with the knowledge base and database. The rule fired and then part will be executed. So D is Y will be executed. An example of an inference chain is like that. Rule 1, if Y is true and D is true, then Z is true. Both Y and D is true, then Z will be true. Then the second rule is if X is true and B is true and E is true, then Y is true. If it satisfies these three conditions, then the action will be executed. Y is true. The rule 3 is if A is true, then X is true. The only one condition should be satisfied in the rule 3. This can be represented in the diagrammatic format. So, the forward chaining is a data-driven reasoning. The reasoning starts from the non-data and proceeds forward with the data. Each time, only the top rule is executed. When fired, the rule adds a new fact in the database. Any rule can be executed only once. The match fire cycle stops when no further rule can be fired. Here the comparison will be taken place with the database and knowledge base rules. So in the database, A will be there. That A check whether any match in the knowledge base. Here A is there. So X will be fired. So X will be added to the database. In the cycle 1, C also there in the database. C will be matched with the knowledge base. So L will be fired. That will be added to the database. And the second cycle, the knowledge base will be matched with the X, B and E. Y will be executed and that will be added to the database. In the third cycle, here have the matches find Y and B, then the Z will be fired. This is the procedure of forward chaining. Backward chaining is a goal-driven reasoning. In backward chaining, an expert system has the goal and the inference engine attempt to find the evidence to prove it. First, the knowledge base is reached to find the rule that might have the desired solution. Such rule must have the goal in their then part. If such a solution is found and if part matches data in the database, then the rule is fired and the goal is proved. However, this is the rare case. Thus, the inference engine put aside the rule. It is working with the rule-based rule is set to stack and set up a new goal, sub-goal to prove the if part of the rule. Then, the knowledge base is searched again for rules that can prove the sub-goal. The inference engine repeats the process of stacking the rule until no rules are found in the knowledge base to prove the current sub-goal. Advantages of rule-based expert systems are separation of knowledge from its processing and the dealing with incomplete and uncertain knowledge. Most rule-based expert systems are capable of representing and reasoning with the incomplete and uncertain knowledge. The disadvantage of rule-based expert systems are opaque relation between rules and ineffective search strategy, inability to learn. In general, rule-based expert systems do not have an ability to learn from the experience, unlike a human expert who knows when to break the rules. An expert system cannot automatically modify its knowledge base or adjust existing rules or add new ones. The knowledge engineer is still responsible for revising and maintaining the system. That's all about rule-based expert system. Thank you.